there's three types of transformations: translation, stretch, and reflection. And all of these can be done either vertically, which means the y direction, or horizontally, which means the x direction. So let's look at translation first. What translation means is to shift the graph. So there's two types of shifts. We either shift in the vertical or the horizontal direction. So as you can see here, if we add a number that's outside of the bracket, outside of f of x, that's a vertical shift. So, and if we add a number inside the bracket, that would be a horizontal shift. So, for example, let's say I have f of x plus 2. So f of x plus 2, the number is outside the bracket. So what we do is we'll add 2 to our y coordinate. So 0, 5, my x coordinate 0 will remain the same, but my y coordinate for the same point, it will go up 2 units. So it will become 0, 7. And my true 1 will become true 3. So my new graph will look like this. So it's a shift 2 units up. So let's say now I have f of x minus 3. So it's the same logic. My 0, 5 will become 0, 2. And my true 1 will become true, negative 2. Right? 1 minus 3 is negative 2. So my graph will go down 3 units. So now let's look at horizontal translation. Let's say I have f of x minus or plus 4. So when we did a vertical shift, when we plus, we went up. But for horizontal, it's a bit tricky. Instead of going 4 units to the right, we actually go 4 units to the left when it's plus 4. So my y coordinate will stay the same, but my x coordinate will become negative 4, 5. And my true 1 will become true minus 4, so it will become negative true 1. So my new graph will look like this. So it's a shift to the left by 4 units. Now, if you have f of x minus 3, right? Again, it's a negative, but it will go to the right. So 0, 5 will become 3, 5. And true 1 will become 5, 1. So my new graph will look something like this. So it's a shift 3 units to the right. So for translation, the graph doesn't change shape, but it just moves. So we can call it a shift, right? Remember your horizontal shift, it goes in the opposite direction. So now let's look at stretching. So again, when we multiply by a number that's outside of the bracket, it will be a vertical shift. So let's say I have true f of x, right? So we multiply f of x by 2. So that means we're multiplying our y coordinate by 2. So my 0, 5 will become 0, 10, right? My x coordinate stays the same. And my true 1 will become true, true. So my new graph will look like this. So now let's say I have half of f of x. So what that means is that I multiply my y coordinate by half. So 0, 5 will become 0, 5 over 2. And my true 1 will become true and 1 over 2. So my new graph will look something like this. So we're either compressing it vertically or stretching it vertically. So now let's look at the horizontal stretch. So let's say I have f of true x. So what that means is, instead of multiplying my x coordinate by 2, we're actually going to multiply it by half. So my 0, 5, well, my 0 times half is still 0, so it remains as 0, 5. But my true 1 will become true times half, so it will become 1, 1. So my new graph will look like this. So now, let's say I have f of half x. So what that means is that we're going to multiply our x coordinate by a factor of 1 over whatever number is inside. So 1 over 1 over 2, that is just equals to 2. So we're going to multiply our 0 by 2, so we still get 0, 5. And then my true 1 by 2, so I get 4, 1. So my new graph will look something like this. So again, you need to memorize that for stretching, a vertical stretch will be multiplied by a factor of a, but a horizontal stretch is multiplied by a factor of 1 over a. Right. And if you look at our graph, we're compressing it horizontally, or we are stretching it horizontally. So now our final one, reflection. So let's say I have negative f of x. So again, when we have a negative outside, right, we apply a number outside of the bracket. It's related to the y coordinate. So it's the same concept as stretching. We're going to multiply our y coordinate by negative 1. So my true 1 becomes true negative 1, and my 0, 5 becomes 0, negative 5. So a new graph will look something like this. And as you can see, right, my graph is flipped vertically. But to phrase it academically, we will write is a reflection along the x-axis, right? The x-axis is this. So now let's look at f of negative x. So again, I put a negative number inside the bracket, so it relates to the x coordinate. So my 0, 5, 0 times negative 1 is 0, right? But my true 1 will become true, negative true 1. So my new graph will look like this. So as you can see, we're flipping the graph horizontally. But again, we need to phrase it academically. So we would say that it's a reflection along the y-axis. So now let's go to composite transformations. So what that means is that we're going to do multiple transformations at once, right? So I want to stress first that order matters. So let's say I have f of x, right? And I want to turn this into true f of x plus 3. So let's identify what kind of transformations there is first, right? So plus 3, right? We know that that's a vertical shift. So vertical shift 3 units up. And we look here, there's a true. So we know that that's a vertical stretch by factor 2. So I'm going to show why order matters. So let's say this is my case 1 and my case 2. So let's say I have f of x, right? And I go translate first. So translate, right? Translate. So my f of x will add 3 to my f of x, right? And then I want to stretch. So what happens is that I'll multiply the entire thing by true. So my final answer will be true f of x plus 6. So I think you can already see it. So now for case true, you start with f of x again. I'm going to stretch first. So now I'm going to times true to f of x, right? And then I'm going to translate. So again, we have to add 3 to the entire equation. So we get true f of x, right? It's a big bracket plus 3. So that's the same thing as writing without the bracket. So as you can see, order matters. So when we're doing a vertical translation, I'm going to write it in green, vertical translation. We always need to stretch first and then translate. So let's look at our worked example. So first of all, let's identify what kind of transformations they are, right? For x, right, our x, we have to translate -1 unit, right? Because we're +1 in the bracket, so we know that corresponds to the x coordinate. So now let's look at outside the bracket. We have true times f of x, so we know that as stretch by factor true. And then we have plus true, so we know that as plus, so we translate true units up, right? Translate true units up. So now let's look at the graph. Let's look at the coordinates. So I want to say first that x and y, the order doesn't matter in which way you do it. Because let's say I translate 1 unit in the x direction, that will only affect the x coordinate. My y coordinate is not affected. So it doesn't matter if you do x first or y first. But what matters is the order between the y's. So let's look at 0, 4, right? So by 0, 4, I'm going to translate 1 unit to the left, right? We'll do this 1 unit to the left. So 0, 4, I'm going to write it here. 0, 4 becomes -1, 4. And then I'm going to look at the y. So remember our order of transformation, right? We have to stretch first and translate. So now we're already done with the x value. So I'm going to put a tick there. So my y value, 4 stretched by true, so that'll become 8, right? And then translate by true units. So it will become 8 plus true, so that'll become 10. So my 0, 4 has turned into -1, 10. So -1, 10 is somewhere here. So now let's look at another coordinate, 1, 0, right? So again, we can either do the x coordinate first or the y coordinate. It doesn't matter. So for this, let's say for this example, I'm going to do y coordinate first. So 1, 0, I want to stretch by true. So true times 0 is still 0, right? And then translate by true units, so plus true, so it become 1 true. So that's our y coordinate done. So now let's look at the x coordinate. I'm going to translate 1 unit to the left, right? So that becomes 0, true. So my 1, 0 becomes 0, true. So now let's look at our last coordinate, 4, 0. So again, let's do x first. So 4, 0 by 4 will translate 1 unit to the left. So we'll get so we'll get 3, 0, right? We minus 1. And then my y coordinate, right? 0 times true, so that's still 0. And then 0 plus true units, so 3 true. So now my 4, 0, I'll move this coordinate to 3 true, so it'll be somewhere here. And one thing I want you guys to take notice before we draw the graph is that even though they didn't give us the coordinate for the minimum point, right? We know that since we're stretching the graph, what that means is that we're kind of stretching the graph vertically. So that means our graph would be longer. So my y, right, it will go down. And remember, our x, we're translating 1 unit to the left. That means our coordinate will move to here. So this is like a rough estimate, but it's pretty important. So my new graph will look something like this. And let's label it true f x plus 1 plus true. And that's my answer.